Welcome to another video of Geosystems. So today's topic is about the new marker support in Imagine UAV. Some of you may probably have heard of Imagine UAV, an automatic workflow to process drone images easily. If you have not, please do not hesitate and visit the links provided. Okay, well, the Imagine UAV workflow is unique. In a nutshell, it processes your UAV images automatically in one go. Our philosophy is this automatic approach without interaction by the user after the workflow is started. Thus, just tell the Untitled Imagine add-on where your data is, set some specifications about the output quality and press the Run button. In the meanwhile, you can focus on your other duties or go on having this coffee break you usually take when waiting to start the next processing step. Here you do not have to bother whether processes have already finished and others have to be started. This just as a brief intro. So we have not spent our time idly. We focused on requests and wishes of customers. We discussed other ways to better automatize the product and get more accurate. Also, we kept in mind the issue about multi-temporal applications. The best approach to target this issue is to introduce markers, so-called geocoded targets in the field, just like natural ground control points. Here on the right you can see how they look like. Our goal was to also automatize this option. Well, we were successful and have already a couple of good examples for construction sites in Norway and Northwest Germany. Well, to fully benefit of the automatically workflow, thus sit back and take things easy while your Imagine UAV program is working. In the case of the implementation of markers, you have to do a little bit of preparatory work. Of course, one has to place identifying marks in the field. This is how they look like. And always keep in mind rules about classical photogrammetry. GCPs have to be equally spread over the entire image block. Hence, spread your markers out. To get the markers, visit our website, go to Products Imagine UAV, and download them there. Print them in a reasonable size and place them in the field. Measure the coordinates for each target to be geocoded. Next, create a text file with the entries of the measured targets. This can look like in my example. Thus, in the first column, the target name, for example target 1, then the coordinates in longitude for the x-axis and latitude for the y-axis, and finally the altitude Z. Now the fun part comes. You go and fly your drone over the project area, capture images of the surface including geocoded markers. Please keep the rules of a normal flight survey. Thus, the overlap of images, a reasonable flight height, as well as a stable platform in mind. Okay, before I open the orientation editor, here in my Untitled Imagine you can see in the left map view an image of one marker to which I zoomed in before. I never do have to touch them directly in Imagine. I just wanted to show you this marker again. Usually in Untitled Imagine, I go directly to the toolbox and Imagine UAV. In the drop-down menu, I select Edit Orientation Format. A window opens where formats can be created or altered. Here is my marker orientation file, Markers. I will show you the corresponding text file again. You have seen it before. Briefly, I want to give you a look into the setting of the different columns in the orientation editor. Here in the lower bottom, you can switch between the preview and the original text file to check whether the settings are correct. I check quickly the first entry and see that the information of the orientation file suits to my column definition. In this case, my orientation file is ready and I click Save and Close. This was only briefly shown now, as there is another Geosystems movie describing the new orientation file editor in more detail. Here in this movie, the focus is set on the implementation of coded targets. I closed the view with the marker, which I opened for visualization purpose only. Again, due to the automatic approach of Imagine UAV, this direct work of manually detecting and measuring ground control points is not needed. What you have to do at your computer is to list the targets in a text file and create an orientation file. These two steps I just showed. Now at next, my default Imagine UAV spatial model is already in the model view, but still not adapted to the support of markers. In general, if you would like to access the model, go again to Imagine UAV drop-down and select View Model. The Imagine UAV spatial model appears in the spatial model editor as you can see it here. Now, besides some settings, I have to add the marker support operator and put it between Create Project and Compute Orientation. Therefore, I pull the operator from the Geosystems UAV Operators toolbox into the Spatial Model Editor. Then I disconnect the mentioned operators to connect them with my marker support operator. This operator now has to be provided with some information. First, I set the marker file format and select Markers. Then I have to specify my orientation text file. The last port you can see at the moment is the marker target type. For this operator, I keep the default circular target 12-bit. Next, I want to show you the properties of this marker support operator. I expand this for a better readability. At first, I want to point to the required ports. The first port UAV project in is already connected to the Create Project operator. Then I define the marker file format, called Markers, set the corresponding marker data file. This is the text file with the geocoded markers, and kept the default marker target type. Now I add 3 further ports by checking them in the Show column: detector tolerance, accuracy for X and Y, as well as Z. The detector tolerance specifies the tolerance used to detect the CTs in your images. Try to increase this value if the markers are not well detected. The accuracy port specifies the accuracy of the marker reference coordinates in X, Y, Z, in meters or in degrees of latitude and longitude. As you can see, the marker support operator has the 3 added ports. The further settings I change to low or lowest. The processing time will be then noticeably reduced, thus I do get a quick result and a first rough impression of my data. I delete the operators which export a DEM and point cloud, hence I only define the output directory for the mosaic. I go and set the directory of the UAV images and run the spatial model. Thank you for watching this video.